And hello and welcome back. So this is the usual writing a programming language in Rust stream. We're approaching maybe the last handful of features, maybe 4 or 5 features in this language. The project that I'm working on currently is essentially research-based language to use as a test bed to play around with different language features. It intends to have a C-style syntax and a lot of the typical features that we'd be used to from a lot of modern programming languages, such as, for example, object decomposition, immutability by default, I think. Actually, I can't remember what I've implemented for this language, but basically just a couple of things that we're used to. And I'll be using that language as a basis for a follow-on project that's provisionally called Ash. It's aiming to be a Bash alternative that tries to keep some of the ergonomics that Bash has around making command running easy, but to add, again, a bit more of a familiar syntax around that, and subsequently add in different kinds of quality of life improvements there as well. The environment that I'm using here, so I run my development environment on a remote host which I connect to using Mosh to get a stable connection. I use tmux to divide that into different essentially workspaces, and then each workspace, so I'm currently in the one for this seed programming language that I'm working on. So this environment is split into 3, where I have my IDE, so to speak. Up here on the top left, I use Vim essentially with just the Nerd Tree plugin and a few custom configurations. I use ENTR on the right to rerun the Rust compiler and test suite whenever I make a change in the editor. And finally on the bottom left, I just have a fairly vanilla Bash instance that I use for running commands. I do use Vim key bindings in that. I think readline has been configured to use the Vim key bindings, and so that's kind of the setup that I have here. Today what I'm hoping to work on is the follow-on from the last day, which is the introduction of interpolated, I was going to say interpreted, but interpolated string literals. So this is going to be the scenario where there's going to be an extra annotation on string literals that will essentially say that this string should essentially be parsed and understood, as opposed to the default string literals where I'm kind of in 2 minds. There are different languages doing different things. So one that comes to mind is, for example, in JavaScript, you have backticks to say that that is a string literal that can be interpolated. It can contain different interpolation directives, and in regular strings as well, even though regular strings with singular double quotes don't support interpolated fields, it does allow for backslashes and escapes. So whether default string literals are going to allow that, I guess it makes sense. Sometimes I think back to PHP as well, where there was a distinction between and I think that came from Bash as well, where there's a distinction between single and double quotes, where one is just the string as is, even if there are backslashes in that or escape characters, and then it's the double quotes version that actually evaluates the escapes. So whether to keep those kind of semantics here, where even in I guess the advantage of having a single quoted version or an uninterpreted version, or one that doesn't evaluate escapes, is that in theory it's a bit more efficient, but is that really, shall we say, like, is that worth the trade-off of not allowing escape characters in default strings? So now that I say it out loud, I think I'll allow for, what's it called, the escape sequences in regular string literals, but in interpreted string literals we'll also do that, but we'll also allow for interpolated directives as well. So there'll be little areas where we can expand variable values. So with that in mind, maybe it would actually make sense to handle string escaping first, because that would be reused in interpolated string literals. So let's see if I can add support for that instead first. And while that's compiling, I guess I'll take a look at this function, which is next string literal. And all we'll really need to do here, I believe, is add a check for a backslash, and we'll add a little boolean to say whether we've encountered an escape. And then if there was an escape, we'll actually change the behavior of the interpretation of the next character. Now, one thing that occurs to me here is that previously we were just taking the range of characters because we were assuming no essentially modification of the substring during the evaluation or during the lexing of the identifier. So also this is saying ID, maybe, oh, I can't call it string. Oops. Just call it S. I think ID is kind of a holdover from the last iteration of this implementation. So the question then becomes, do I build up a new string? And that might make the most sense. Is there an efficient way of creating or building up a string character by character? Let's just see here. Yeah, so we could use with capacity and push string. Yeah, I think I read before that for most cases just using plus equals is going to give you fairly good performance anyway. Yeah, so we're talking about very low overheads in general anyway. And these are going to be very short strings in general, I would say too. So and again, this is maybe a bit of a crude way of implementing this too. We could probably use some kind of a pattern match. I guess those are the only two scenarios. Well, actually, there would be the case of new line, things like that. Let's see. Return, tab and backspace. Form feed and octal and hex values would be useful as well. At the very least, hex values anyway. So yeah, let's go ahead and add support for those. That isn't supported. Escape sequence in Rust, it would seem. And to support hex characters, we will also need some extra state management, I would say. are we with that compile actually? So in mod next interpreted. That's all I needed to change there. This feels a little hacky, but as ever. I'll remove, well, yeah, let's go ahead and save that first and see if Rust actually puts up an error for the form feed issue. I'll be able to use equals there unless I think I can do drive. so that's an unknown character escape. And we want to parse that as well. So I want to say if it's in a certain range, I presume there's some logic around here. Yeah, so we want if it's an ASCII digit. I wonder if there's a function for hex digits. Oct digit, hex digit. Yeah, so that seems to be what I'd want. And so I want to parse that. And do I want to catch the error in that case? Or at least do I want to dive into the specifics of that error? Because if an error occurs, then I can be fairly sure that's because it's an invalid character. And next comes the issue of for string literals, they have to be valid Unicode. So there could be an issue there. But what I'll do is I'm not sure. I guess I will just push the bytes onto the string and use the general lossless conversion, which would throw an error if it's invalid. So that's going to make some valid strings unrepresentable, I think, but that should be okay. I'm just thinking how this is going to work now. So if I'm building up the string this time in terms of U8s, then let's see. guess I'll just push them in. Oh wait, U8 can store a 256. Yeah, the value of it, U8 goes up to 256. So we'll go ahead and push that on. So we'll have to handle the error, but other than that, it should be close to what I want done. Now I'll need to do a string from bytes. That will give a UTF-8 error if there is an issue. Just make it string for now. Okay, and we have a Lex error type, so now we can have a couple new errors. We'll also have UTF-8. think that'll go. So let's see, 173. Do I have to import something to use from UTF-8? Do that. 272, what's the issue here? Oh yeah, so that'll just be adding some error handling. So there's some encoding mismatches, and it's just a matter of figuring out what's the best way of moving past that. I guess if I have an array or a vector of characters, that would probably be the easiest. If there's an easy enough way of converting it to a string, and there does seem to be, so iter collect. So maybe we'll do that. Then it becomes a matter of converting the hex item to a character, which could possibly do the invalid UTF-8, which would make more sense anyway in terms of error handling. It would give us the error closer to the point of it being raised. So first we have invalid hexadecimal character. Yeah, things could get a bit messy around here because it'll essentially just be saying that you can use, so even if you have a sequence of hex bytes which would effectively make a UTF-8 character, they'll be put into separate individual characters, so that won't be possible. I'd probably need a separate escape sequence for handling UTF-8. So I guess just using as char will actually do what I want, and we might not have a UTF-8 issue. Depends on how tightly that binds as well. Yeah, so it binds pretty tightly, so I need to separate that. Can I do something like that to make it pretend that it's a string? Probably not. I'll probably need to do some specific conversion. Also need to take the address of that. Yeah. Okay, well that seems to be about as much as I need, but I'll also add in support for Unicode, or at least UTF-8. Because otherwise UTF-8 characters won't be representable using hex sequences. So we'll take a look at that next as well. That block a little messy, but I'm not sure can it be easily avoided. Cool. I'm kind of glad that I don't know, this was, I would say, not too challenging of a feature to implement, but for whatever reason I had hyped it up in my head a little. I was thinking there are all these special edge conditions to consider and things like that, but that's just not the case. So let's try adding a few parse errors. So one might be, well, there are a couple of things to add here. So if I were to add x, or let's see, let's see what happens when we cut that short. Well, it'll say that that's not a valid hexadecimal character. Let's try those. And it will be line 1, and let's see, character 1, 2, 3, 4, I guess, and same down here. Okay, so that's ending up on character 5. 1, 2, 3, 4, 5. And tragedy. Hi, welcome to the stream. I wonder, is there a way to... Well, there is a way, but an easy way of correcting that location. So we've got the location here. So let's try that to get the correct character. And then we say G is not a valid hex character. Is it spelled like that? So decimal. Yeah. The way it was, just to keep it within my character limit. And for some reason that's going on to the next line, but I would say that's for the same reason. And so that's more or less it for the errors, it seems like. So let's take a look at the actual results of parsing. So features, functions, where should this go? Parse errors, print, return, stack trace. Maybe I'll create a new one called strings. So let's see, we'll just go print what? We'll go new line and carriage return. I'm not sure if I'll actually be able to print those, we'll see. What were the errors before? So the messages were correct, it was just the line numbers were off. So I wonder, did the change I made for current location get picked up? We'll see. It didn't seem to. Okay, I'll try it one more time. Okay, one of the errors got resolved. Okay, but that should still be line or character 5. 1, 2, 3, 4, 5. Okay, yeah, that's actually correct. Hi, Unicode, welcome back. It's going well. How are you? So we'll change that to character 5, and then we also have an issue with the new, or with the escape test, unexpected EOF. Now, what was going wrong there? Oh, because I need a semicolon. Yeah, let's try that. That's an interesting output. Not quite what I was expecting. So let's see. So escape new line still had an unexpected EOF. Am I possibly not clearing the state properly? So I'm going to change the state back to none here. Okay, so we're getting different errors for different situations. So at least the issue with the hex codes is kind of consistent. So it's giving me \F and then backslash as the encoding. I'll just do a sneaky output here. Let's try that. Okay, so it didn't seem to actually output my... Oh wait, that's format, not print line. Okay, so we had 66 and then 86. So it does seem like I'm getting the order backwards. Oh yeah, first hex char is N. So that should be H. But I'm still getting the same output. So go N, H, N. 6 multiplied by, let's see, oh, am I doing, so 65 is the decimal value for A. The hex character is 41. Of course. And we still have an issue, so the backslash is getting rendered. So why am I doing that? Let's try that. Okay, it's still getting this issue with the unexpected end of file, so let's go ahead and try and separating those. Okay, so we get it for both. Am I not? I'd say I'm not toggling off the state. I just have too many new lines. So escape carriage return. Not really sure how I can test that. basically that done. Let's see, will we add some documentation and some features. Oh, I forgot about tab as well. Nah, I'll leave that out. I'm not too big of a fan of tabs, so I'll leave it out of the current implementation. And that's basically it for documentation. So we have our common escape sequences, implement Unicode escape sequences now while it's somewhat fresh, even though I feel like I could be doing something a little more interesting. Oh, nice. That sounds cool. So, how to create a string from a char? No. I'm wanting to see, is there let's see, UTF-8. Yeah, let's take a look at a table. I just want to create a sequence that demonstrates how the hex characters can't be used in place of Unicode and the Unicode that would be used to demonstrate the same thing. So let's see. Yeah, thanks for the question. In terms of difficulty, I would say there have been a few challenges, mostly due to Rust, I would say, and trying to figure out how to work around the borrow checker for the most part with implementing a language, because especially in this language, the lifetimes aren't so clear. And even if you're writing kind of any language on top of Rust, I don't think in general you're going to be able to keep the same lifetime assertions in the implemented language as they are in Rust. So there's a bit of, I guess, mental conversion needing to go into that. And there have just been various times where I've assumed a certain implementation did it for the most part and realized there'd be a bug or something like that in it that I'd overlooked. But for the most part, I would say 80% of it is really just not necessarily donkey work, but just putting the head to the grindstone and doing the implementation. And Motolang, I don't think I've heard of that. Hi, Kantorin, or Countorin. I'm probably butchering the pronunciation, but that's my best attempt. So I wonder, let's see if I check some maybe Japanese characters and see what, I guess, codes they're made up of. Okay, yeah, that would be cool. Motolang. Countoren. Okay, perfect. Thanks. Motolang. Yeah, that's got a nice ring to it, actually. Yeah, so what are some... So C2... Let me see. Because I want to have something that is visible both in the UTF-8 format but also in its raw ASCII format. Okay, I'll have to make sure to change the ideas just enough to skirt by that clause. So let's see, C2 was it? Okay, once we're getting into the C's, we're kind of getting into ANSI rather than ASCII. So let's see here, there. Okay, so that's regular ASCII. I wonder if what I'm wanting to do is very possible. So we've got basic Latin. Oh yeah, so let's take a look. We might have Japanese somewhere here, just because I'm some little bit familiar with Japanese, so we have kana. Would that constitute it? So we have katakana, hentagana, so kind of, if it was called like kind of warped kana, I guess, or kind of unexpected kana. Not sure. Okay, hiragana and katakana. So E3, again, yeah, we're out of the range of, I guess we'd want from 2 to 7 in terms of the starting characters. Yeah, I'm not sure if what I want to do is very possible, but yeah, I think I'll leave it because I can't do it the way I want it, so I'm not going to do it. So we'll skip UTF-8. That'll be fine for the moment. This isn't gotta be a production level language anyway. It's for research purposes, so that's my excuse for the moment. So there's interpolated strings to do. Let's see. Will I try and knock out a bit of that? I guess so. And would I add it in here? Well, we would use the same parsing for the most part, and the time when it changes is during the evaluation. I'm not sure I need that anymore, do I? Oops. Yeah, so I can actually have gotten rid of that. So in this case, we're really just changing it from a string literal to an interpreted string literal. For the moment, I won't actually output it. I'll just figure out how it's going to be handled when it's used. So I'll update the AST. Yeah, to have an interpreted flag. And that'll start off as false. But if interpreted is true, then we'll add some extra processing. So I'll just use integers to represent the state for the moment. So if we've encountered $, then we're in state 1 where we're matching an interpolation. Stage 1, we will be looking for an opening parentheses, and it will take us to state 2. There's definitely a better way of doing this, but actually this could be quite tricky because it might require triggering the parser on the inner section of the string, of the interpolated block. It kind of depends on how much logic should be allowed in that inner code block. So the simplest is to allow variables, but would be nice to be able to allow for dereferences, for example, for array lookups and things like that, and function calls. But that would actually be surprisingly tricky now that I think of it. If it's going to be parsed at this state. Now, whether I can whether I can shoehorn it into the usual parsing step. That would also be tricky because the parsing is being done in a way that delegates the lexing of the string to another layer, so that that string basically gets returned to the parser fully formed. And what we're wanting to do is to do additional parsing in that string. And one other issue is that we're passing, or the parser itself is actually generated. Oh, I was thinking it's not really accessible to the evaluator, but it would be accessible, I believe. So I could call the parser and I could have potentially, instead of having the program parser, I could have just an expression parser. So it doesn't really allow for unlimited flexibility. There is a limit to it. Like you won't be able to put statements into interpolated blocks, which makes sense as well, to me anyway. Okay, so what could be done? So there are a couple ways this could be done. In short, I'd probably want to be doing something like this, just initializing a new lexer starting from the opening brace, doing an expression parser, or creating an expression parser to parse using the lexer, and then if it was possible to continue the parsing after that point, or the interpolation of the rest of the string after that point, that would be nice too. And what I would do down here is evaluate the expressions that got returned from each interpolation basically as they occur. Like in theory, that could be very straightforward. I feel like the final code for this could be quite straightforward, but I see a lot of tricky bits with the type system and things like that in the meantime. Especially around the kind of lexer and dealing with the, shall we say, token stream. If I didn't have it as a regular string, if I was able to convert it, well, maybe if I and I defined the lexer as well, didn't I? So it's a custom lexer. So I can actually use that and my own functions to read up until the point that I find these characters. This is getting kind of interesting. Okay. Now I'd have to make a lot of those public, but that's okay. I would nearly need to have access to the underlying scanner actually. So I'll do it as kind of a mix of pseudocode and just playing around, but essentially what we're wanting to do is, while peak char isn't end of file, if the character is $, yeah, we can do that state tracking approach to move between the tokens, I think. And so once we get to this point, we've started the identification of an interpolated block. I'll have a new expression parser. I wonder, do I need to have a new one for each block? I'm not sure. But essentially what we can do is we'll be able to do parser, parse, lexer, do the usual and then we'll eval AST, or it'll be eval expression, because we'll be expecting, yeah, the expression parser will return an expression at that point. We'll pass in our existing eval context and scopes and global bindings, and then our AST we'll want to match the result depending on its value. We will render it in different ways. So we would have, for example, string we render by default, and then we'll have the primitives like int and bool. We'll convert to strings, and then for complex types we'll actually output an error. What we could do is have a special directive, a debug directive similar to Rust, which would just be like a pound symbol or something to put it into debug mode, or to just use a default formatting for outputting kind of more, shall we say, composite types. And then by that stage we just assign that to a new string and push it onto new. And I feel like that could work. It's complicated-ish, but also straightforward in its own way. The logic is fairly straightforward, but there are good few moving parts, so I need to tackle those one at a time. this could be a little cheeky, but I'm just going to expose make the scanner a public field for the moment anyway. Okay, so we'll also need to have support for escape characters too, like we had before. Yeah, so this is a tricky one. I wonder, can I just say that you're borrowing it? So it seems like the lexer can't be reused because it's being consumed. Let's see. Do the Ladderpop docs have anything to say about reusing the lexer? Or, oh, can we do it that way? Okay, that seems to have resolved it. This would be very cool if it worked. And if it worked as somewhat easily as it looks like it's being set up to be at the moment. Let's see. And so what does the val expression return? Returns a val ref with source. And how do I use those again? So if I go into one of the built-in functions, for example, I do assert string to get a string from a value. So yeah, we would have to do an unlock here. We're just going to allow strings. bring us to state 2. State 2, we just say we need closing parentheses, and then at the end as well we want to make sure that we're in state 0. So what's my best bet here to convert it into a string? Probably want to do my usual let's try that. Oops. Let's see. Okay. That's kind of exciting, and it would seem a little too good to be true in a way, but let's see how it goes anyway. I'll add some interpolation tests next. Okay, because strings are not interpolated by default at the moment. So we just make it so that all strings are interpolated at the moment. So let's see. that will go into the parser. Hopefully that doesn't like bork a bunch of the tests, but we'll see. That's interesting. So something has frozen, and definitely a lot of the tests seem to be running a lot slower because, I mean, it is running a nested expression parser in a bunch of them. And in fact, if I stop everything, stuff is not after halting. So let's see. Okay, those have calmed down now. Let's see. Let's try running the strings tests again. Doesn't bode well that so much time is being taken with these. That doesn't bode well. So, out of memory issue. Something clearly isn't doing the right thing. might be no harm to run the program manually for a test or two. So let's see. And if I go ahead and it's in target debug, build, I guess if I just run seed. I guess not. So debug, build. I think one of the old processes showed me where it could be. Target debug seed. Oh, I'm running it in the build environment. And it's app target debug seed. Okay, and so if I do app underscore test, let's try that. I'm expecting that to run out of memory, which it looks like it will do at some point. Let's try that. Just so we can get some output while we're running. And I won't spend too much longer on this, even though it's very interesting to me. But it's getting to that point. So let's see. I would guess that this will show us fairly quickly where stuff is hanging. Yeah, so it's not actually moving on from, oh, because I'm doing peak char instead of next char. So there I would do next char. Yeah, at all of those I would do next char. So it's just constantly building up that one string and it eventually runs out of memory. Okay, and it's saying value isn't a string. I wonder what it is then. object. With a property called name. Oh, okay, it actually parsed this section as an object, and name got interpreted as a key with its own value. That's very interesting. Again, I need to actually eat the character that I'm scanning. And I have to do the same down there. Unrecognized token brace close. Because, yeah, how to denote to the inner parser that an ending brace is valid. That in this scenario, an ending brace actually constitutes the end of the file, essentially. Well, I think that's a question for another day, even though I don't much fancy my odds with the amount of context I have in my head right now. I hope I don't leave it too long before I revisit this, because that could be a little tricky to get back into the frame of mind that I have now. But in theory anyway, that's very cool that I was able to use the lexer, and specifically it's nice that ladderpop also exposes all the sub, I guess, parsers for handling different terminals, so that I could just parse an expression on its own. Now that is one thing I could do, is have a special parser made just for this scenario, and it could be like parser for expression 1, and it will only allow for parsing objects with that specific syntax. So we might say, let's see, I wonder will this work, but we can take a look anyway. And I would take out the parts here that eat the braces, I think. I would just send that back to state 1. And I think I'll get an error here because of the unexpected closing brace again, but if I compile, oh no, that actually worked. That's very cool. Let me try something. Unexpected dollar symbol. Is the parser, or is the parser trying to parse beyond the last brace? That would be kind of annoying. Anyway, like I say, that's an issue for the next day, I think. That would, and I also forgot to push the code that I did earlier. So that's an interesting amount of work done today. Anyway, we got escapes implemented with all the typical escape codes and got to work on string interpolation, which turned out to have a lot more complexity hidden inside it than I was expecting, but a lot of that could be resolved by recursive application of the code that we've already used in terms of the lexer and the subsection of the parser that deals with just parsing expressions. Now, there might need to be some figuring it out in terms of delimiting the parser and making sure that it only reads as far as necessary to capture one expression. But it's now, what could be possible is to almost pre-parse the string and retrieve that chunk of that substring of the overall string and pass that to the parser and kind of preemptively tell it where the end of the string is. I wouldn't like that quite as much, but at least that's a way forward if it becomes necessary. But yeah, that's really interesting. that's a really fun puzzle to resolve in this part of the language, actually. So yeah, thanks to everyone who's checking it out as usual, and yeah, I'll be leaving it there. So thanks very much, and talk to you again.